I'm Max Doolin. I'm the founder of the Spokane Cyber Cup, and this is the final or fourth challenge in the Airline Code series. In the first few challenges, we learned all about QR codes. We learned about how to read them, how to modify them, and now we're going to have to do something that's a little bit different. So if we read the prompt, it just says the final section of the ticket is a checksum. For a reminder, this is the final section, and we didn't know what that was before. Modify the ticket with the flight number 9675309 with a valid checksum. Hint, a checksum is a value derived from the rest of the input to ensure the data is not corrupted in transit. And this is a fairly common technique that is used. I think it's used in TCP, for instance. And there's a lot of different types of checksums. Sometimes it's just really simple math. Sometimes there's some XORs involved. Sometimes it's just an addition. The idea is if some data gets corrupted, you want to know that before you actually take it in. And the way you do this is you have some sort of math that occurs over all the values, and then you append the result of that math at the end of it. And this is a checksum. And the big thing that's different in this challenge is now we actually have the code for it. And this is just a Arduino sketch that's about 200 lines of code. It's pretty small. And the main thing that we want to look at is this check here. This is the checksum check or the final fourth flag check. Now, if we just look for the word checksum in here, we'll see it in our ticket, but there's also some other spots we'll see it at. We'll see it in here. For every field that's less than 9, and we can see that there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be all of these fields. Then it's going to do something with those. The thing that it does over the top of it is it just adds the input that we're looking at. So the particular character, it takes the numerical ASCII representation of that character and adds it to the checksum. Then later down here, it checks to make sure that our ticket's checksum matches the checksum we brought in mod 256. So there's a 256 chance you get this right if you're just randomly guessing at it. But it's checking to make sure the checksum that we provide matches the checksum that's being calculated by the program. And there's an additional check that the flight number is set to this value. So how do we actually do this now? Now, what is the actual mathematical procedure for this? Well, I wrote up a little bit of code for this. If we look at just this test.py right here, here's the math. It's taking all of the characters prior to the final checksum check. So the checksum would be here. But it's taking all of the characters, and then it's doing some mathematical operation over the top of it. Mathematical operation is taking the ASCII representation, which you can use the ORD for in Python to do. It's adding it to the previous one, and then it's modding it by 256. And this puts it in the range of ASCII characters from the standard ASCII table. So I just read this in the Arduino code, and I implemented this in Python. Now, if we do python test.py, we'll get some number, and this number is all of the ASCII characters added together. And then we mod this by 256, we get 42. So that means that the star character is going to be the one that we want to use in that case. Yeah, so that's how a checksum works, and this is the premise of the challenge. Now, I already put this in here, and I probably should have waited to do this, but this is the other part to the challenge. We need to set the flight number to be this value, and if we go back here, and we actually look at the code, you will see that the flight number is the third field, and that's why we set so it's this one. So that's why in our code, we set the flight number to be, this field to be the 9675309 value. Now, there's a little bit of a trick to this, and I'm just going to do this first so we can see what this looks like. But if we keep this value, which is kind of the default one that I have set up right now, then we get a star. If we go back to our website we've been using for generating QR codes, we can generate QR code without a checksum, but of course that won't work. So we're going to add the checksum. This checksum is the star that we just calculated. Now if we do a scan right there, we can see that it adds a new flag. Oh, that didn't work. Why didn't that work? Let's make sure I copy this thing correctly, I suppose. I'm going to do star. Oh, I didn't refresh it, I don't think. I didn't refresh it. That's why it didn't work. Maybe. Yeah, so now we can see that gave us a flag, and it's checksum with a bunch of weird characters in it. So there is a little bit of a trick to this, though. So one really hard thing is that this has to be a printable character. And what if you use something that's not easily printable, like a tab or a new line? And you have to be a little bit creative with this. So the way this checksum is calculated is it adds up all of the values that are there. And some of these values don't matter, such as this one. So there are situations where this may not be a printable character. And in Python, to print it, you can just do CHR with a number. And this is the opposite of ORed. This will take a ASCII value and turn it into a character. So say we did this. Well, the ASCII value here is going to be 249. Yeah, I guess you could put that in there, but just for the sake, let's do something that's like a regular character or a number or something like an @ sign. We can change this to be what we need. So because this wraps around, because the modulus, if we add in a 2 here, for instance, we can change the values being used. And when we do that, now it's a plus sign. So one of the tricks here is just changing the values within the rest of the ticket to give you a printable character to then be used. For the students, I'm guessing they're probably going to struggle to figure out the algorithm. Reading code, in particular code in a language you're not familiar with, is hard. And this challenge is supposed to be harder. So just asking, hey, what is this code doing right here? What is it checking at this point? And just asking comprehension questions for what I explained is a good way to get the students to understand this correctly. Yeah, so to recap, we have a checksum. And a checksum is a value that is some sort of mathematical operation over the rest of the values. And this checks to make sure that the value was sent over correctly and it hasn't been corrupted in transit or modified in some way. And to figure out this checksum, you need to read the code. Reading the code, we can see the checksum new, we're adding it to our input, and we are then checking that our checksum from our ticket is the same as the checksum new, which is the mathematical operations being performed, mod 256. And of course, it has a flight number. Once we build this out in our QR code and we scan it, we get the flag. Hope you enjoyed the series. This is one of my favorite challenge series I've ever written, and hope you guys had a good time with it. Let me know if you have any questions. Thanks. Bye.